Hello guys, in this video we are going to talk about the chapter test of chapter 6, laws of integral indices. So first question is talking about to simplify each of the following expressions. The main point is to put them into positive indices. So a lot of students still give me a negative indices, or some of them didn't simplify it. So for the first questions, we have a to the power of 5 times a to the power of 3. So we can, using our formula, a to the power of m times a to the power of n is equal to a to the power of m plus n. So when you times two things with the same base, so we can plus the power together, which means that we can write it as a to the power of 5 plus 3. So the answer should be a to the power of 8. So for second questions, we have b to the power of 4 times 4b squared. So in this question, some of the students don't understand the meaning of 4b squared. So 4b squared basically is just the meaning of 4 times b squared. So in this question, we can just write it as 4. We're taking out the numbers first to the left-hand side. So we have 4 times b to the power of 4 times b squared. So in this formula, in this equation, we can then using this formula again to getting our answer 4 times b to the power of 4 plus 2. So the answer will be 4b to the power of 6. Our next question is number 3. X to the power of 3 divided by x to the power of 6. A lot of students make a mistake from here, but the first step is to change it into a fraction first. So we have x to the power of 3 divided by x to the power of 6. Then we have to use our the formula, which is a to the power of m divided by a to the power of n. If we divide by two powers, we can minus the powers. So we have a to the power of m minus n. And using this formula directly, we can get x to the power of 3 minus 6. Be careful, this one will give you a negative power with x to the power of negative 3. So again, using our x to the power of minus n, we're giving you 1 over x to the power of n. So which means that it can be writing as 1 over x to the power of 3. So be careful if you're writing this one as a final answer. Even though it's correct, however, you cannot get the answer marks because the question is asked you to answers with the positive indices. In this one, we got a negative. All right. So for the next question, number 4, we have 7y to the power of 8 divided by 14y squared. So first of all, we can separate it into two things. We have 7 over 14 times y to the power of 8 divided by y squared. So in this questions, so in this part, 7 over 14, we can simplify it by dividing their common factor, which is 7. Then we have 7 divided by 7 giving you a 1. And then we have 14 divided by 7, which will give you a 2. And for the right part, we have y to the power of 8 divided by y squared. So we can use this formula again on this part. Then we can have y to the power of 8 minus 2. So the answer should be y to the power of 6. And we combine them together to get a half of y to the power of 6. Now we're moving to number 5. We have a cubed times b to the power of negative 4 divided by b cubed. So in this question, we're going to separate this whole fraction into two fractions, which means we have a to the power of 3 times b to the power of negative 4 divided by b cubed. So we always separate our fractions into the thing with the same base. Then we can, using our formula of a to the power of n divided by a to the power of n is equal to minus the powers. Then we have a to the power of 3 times b to the power of minus 4 minus 3. Then we can say this is equal to a to the power of 3 and b to the power of negative 7. So again, we got a negative power. We need to change it back to positive. So we have a to the power of 3 divided by b to the power of 7. Alright, moving to the 6 questions, we have 6x cubed y squared divided by 4x y to the power of negative 1. So we have three parts, the constant parts, the x variable, and the y variables. So we can change it to 6 over 4 times x cubed divided by x times y squared divided by 1 to the power of minus 1. So now we have, so because 6 over 4 they have the common factor of 2, then we can divide both of them by 2. So 6 divided by 2 and 4 divided by 2 to get this 3 over 2. So this one can be simplified to 3 over 2 times x to the power of 3 minus 1 times y to the power of 2 minus d minus 1. So 2 minus minus 1, 2 minus will give you a plus, so this is equal to 2 plus 1 will finally give you a 3. So this is equal to 3 over 2 times x squared times y to the power of 3. Then we can combine them together to get 3 over 2 x squared y cubed. So that's the answer for question 6. And now we can move into question 7. So question 7 is asking 5a to the power of 0, b to the power of 5, all the thing to the power of squared. So in this question, we can use our formula of ab to the power of n is equal to a to the power of n times b to the power of n. So we can distribute 2 to both of them. But however, in this one, a to the power of 0, which will give you a 1 directly, so we can simplify it first. So we have 5 times 1 times b to the power of 5 squared. So 5 times 1 gives you a 1, and we take this power of 2. So we have 5 squared times b to the power of 5, the whole thing squared. Then we can use our formula of a to the power of n outside the bracket, get another power. We can times the powers together. So this question will give you a 25b to the power of 5 times 2 will give you 25b to the power of 10. So that's the answer for question 7. And for question 8, we have 2x to the power of negative 2 divided by x squared, y to the power of negative 3, all the thing to the power of 3. So we can do something inside the bracket first. So we can simplify something to get our... So for example, we can move this negative 2 back to the denominator. So we can get 2 over x2 to the power of 2. However, for this y to the power of negative 3, we can throw back to the numerator. So we can get y to the power of 3. So all the thing to the power of 3. And we simplify the things inside the bracket. We can have 2y cubed divided by x to the power of 4. And outside the bracket, we got a power of 3. So we're again using a over b to the power of n is equal to a to the power of n divided by b to the power of n. Then we have to distribute this 3 to all of these factors. Then we have 2 cubed, y cubed, the whole thing cubed again. And then we have x to the power of 4 and the whole thing to the power of 3. Then we simplify to get 2 to the power of 3 again. 2 to the power of 3 is not equal to 2 times 3, but it's actually equal to 2 times itself, or 3 times, which is equal to 8. Then we have this is 8y to the power of 9 divided by x to the power of 12. So this 9 is coming from this 3 times the 3. As I said before, a power of a power can just times the power together. And this 12 is coming from this 4 times 3. All right, so next page, we will move into our question 9. So question 9, what we have is negative a squared b to the power of 0 divided by a to the power of negative 1 b to the power of 4 all squared. So in this thing, we can simplify something first. For example, we can simplify this b to the power of 0, which is equal to 1. And then we can move this negative power back into here. So which means that we have the negative a to the power of 2 plus 1 times 1 divided by b to the power of 4, and the whole thing squared. Then we can have the negative a to the power of 3 divided by b to the power of 4 squared. As we have this negative, so we have this negative 1 squared times a to the power of 3 all squared divided by b to the power of 4 squared. So the formula we're using is just to distribute this 2 to this a cubed, to this negative, together with to this b to the power of 4. So we simplify it, negative 1 squared gives you a positive 1, and then we times the a to the power of 6 divided by b to the power of 8. So in this 6 is coming from this 3 times 2, a power of a power, so you have times the powers. So b to the power of 8 is coming from this 4 times 2. So the answer will be equal to a to the power of 6 divided by b to the power of 8. Moving to question 10, what we have here is x squared y cubed divided by x to the power of 4 y to the power of negative 1, all the thing to the power of negative 3. So first of all, again, we can simplify something with x and something with y. So basically we can just do x to the power of 2 minus 4, and then we can have times y to the power of 3, or we can separate it first. So x squared divided by x to the power of 4 times y cubed divided by y to the power of negative 1, just in case you didn't understand why I can do them directly. So after we separate it, then we can do this thing to get x to the power of 2 minus 4 times y to the power of 3 minus 1, and the whole thing to the power of 3. So again, in this part, we're using our formula, a to the power of n divided by a to the power of n is equal to a to the power of n minus n. So now we can separate it, we can simplify to get x to the power of negative 2 times y to the power of 4, and the whole thing to the power of 3. So again, if we have something like a to the power ab to the power of n, the n can be distributed to a and distributed to b. So we have a to the power of n times b to the power of n. So this one we can distribute this 3 to n, then we have x to the power of negative 2 bracketed and to the power of 3. Then we times y to the power of 4, all the thing to the power of 3. Then we can use our formula, a power of a power will give you the power times each other. Then we have x to the power of negative 6, y to the power of 12. So again, this is a negative power, we can switch it back to the denominator. We have y to the power of 12 divided by x to the power of 6. So now we are going to talk about question 11. We have a squared divided by b to the power of 4 squared, a over b to the power of negative 1 to the power of negative 3. So in this question, it looks like it's very hard, but however, we can just do them separately. So first of all, we can distribute this 2 to this a squared, and here, similarly for this negative 3 power, can give both of them as well. Then we have a to the power of 2 times 2 divided by b to the power of 4 times 2. And then we do the right part, we have a to the power of negative 3 divided by b to the power of negative 1 times negative 3. And then we simplify it, we can get a to the power of 4 divided by b to the power of 8 times a to the power of negative 3. And in this one, 2 negative times together will give you positive, so this is a b to the power of 3. And then we can combine them to get a to the power of 4 plus the minus 3 times, it's over. So we're over the denominator, which is b to the power of 8 plus 3. So the answer should be a over b to the power of 11. Now moving to question 12, we have x cubed y to the power of negative 1, the whole thing cubed, divided by x over y squared. So we just do them step by step. First of all, the 3 can be distributed into the x cubed together with the x negative 1 power. Then we have x to the power of 3 times 3 times y to the power of negative 1 times 3. And what we want to do is to divide it. These 2 can be distributed in both of the numerator and denominator to get x squared divided by y to the power of 2 times 2. So again, if you divide a over b, which is basically just times the b over a, so the divide can be changed to times, and we revert the fractions. So this is equal to x to the power of 9, y to the power of negative 7, negative 3, times y to the power of 4 divided by x squared. So we can put the x together and put the y together. Then we have x to the power of 9 divided by x squared times y to the power of 3 times y to the power of 4. Then we're using our formula of a to the power of m divided by a to the power of n is equal to a to the power of n minus n to get x is equal to 9 minus 2 times y to the power of minus 3 plus 4. So the answer is x to the power of 7 y to the power of 1, which is basically just y. Okay, so that is the first part, and now we are moving to our next part. Without using a calculator, find the values of the following expressions. So kind of the student with the algebras find it's harder, but it's actually just some numbers. So question 13, we have 4 times 6 to the power of negative 2. So first of all, we can change our negative power into positive power like this by using a to the power of negative m equal to y over a to the power of n. Then this is equal to 4 times 1 over 36. So lots of students stop doing like this, so also after they're doing this step, they stop. But actually, 4 and 36, they got a common factor. They can simplify it to become 1 and 9. So the answer should be a ninth. So next question 14, we have 2 divided by 3 to the power of negative 2. So first of all, we can change it back to a fraction. So 2 divided by 1 over 3 squared. Then using the formula that I taught before, divided by a over b is equal to times b over a. So that we can have 2 times 3 squared over 1. So 3 squared will give you 9. 9 divided by 1 is 9 again. 9 times 2 is 18. And now moving to question 15, we have 10 squared divided by 2 to the power of negative 1 times 5 cubed. This question is a little bit tricky, but please remember that if the base are not the same, then please don't times them together. It's wrong. Alright, so in this question, we can separate as a tip. We can separate this 10 to become 2 times 5, right? So you can separate this 10 to become 2 times 5 squared divided by 2 to the power of minus 1 times 5 to the power of 3. So now we can distribute this 2 in both of 2 and both of this 5. Then we can have 2 squared times 5 squared divided by 2 minus 1 times 5 cubed. Now we can do this part first, then we do this part. So this is the first one, this is the second one. Then now we can have 2 to the power of 2 minus 1, and then we times 5 to the power of 2 minus 3. Then the answer should be 2 to the power of 2 plus 3. 2 plus 1 give you a 3 times 5 to the power of minus 1. So in total, the answer should be 8 over 5, because 2 to the power of 3 is equal to 2 times 2 times 2 for 3 times. Now we got 2 times 2 times 2 is equal to 8. So the answer for question 15 is equal to 8 over 5.